Hi there. In this section, we are going to learn another subtopic that is related to graph data structure, which is single source shortest path problem. Basically, we have three algorithms for solving this problem, which are breadth-first search, Dijkstra's algorithm, and Bellman-Ford algorithm. Now, before continuing to the solutions of single source path problem, let's first identify what's the single source shortest path problem. By definition, a single source problem is about finding a path between a given vertex, which is called source vertex, to all other vertices in a graph, such that the total distance between them, source and destination, is minimum. So we can make this definition clear by using a real-life example. So let's say we have offices in 5 different cities, and we need to travel from head office to all other offices, and the flight charges between cities are known. So we need to find out the cheapest way to reach out from head office to the other offices. So let's say we have our offices in 5 different cities across the Europe. So we have office in London, we have office in Paris, we have office in Rome, and we have another office in Barcelona, and we have another office in Berlin. So let's say our head office is located in London. So we need to find out cheapest flight from London to the other branch over here. Now these arrows over here shows the flight between these cities, and the numbers on these arrows shows the flight charges between these cities over here. So we need to find from any given vertex to all other vertices the path with the minimum cost. So as we said before, our head office is located in London, so we are going to find a path from London to all other cities with the cheapest price. As we mentioned before, we have various options to solve this problem over here. Basically, if we implement an algorithm for solving this problem, the result will be like this. So in this case, from London to Paris, we have to fly directly, and from London to Rome, we have to go to Paris, and then we have to go to Rome. This is the cheapest flight. So from London to Barcelona, we have to first go to Paris, then Rome, then Barcelona. So this is the cheapest way in this case. So as you can see, here from London to Barcelona, we have another way. For example, if I go through Berlin, in this case the cost is 30, but if I go through Paris, Rome, and Barcelona, in this case the cost is 25. So this means that this is the cheapest way. So by solving this problem, we can get the answer like this by using 3 different cases. So as I mentioned before, we can solve single source shortest path problem using 3 algorithms. So in this case, we can use breadth-first search algorithm, Dijkstra's algorithm, and Bellman-Ford algorithm. So we are going to talk about these algorithms one by one. First, we are going to start from the breadth-first search algorithm. So we know from previous lecture that breadth-first search algorithm is an algorithm for traversing graph data structure, which starts at some arbitrary node of graph and explores the neighbor nodes in the current level, then moves to the next level. So it means that if you have a graph like this, first it's going to visit all nodes that are located in the first level, then it's going to continue to the second level, then it's going to continue to the third level. So in this case, the order of visit will be like this. So this red arrow over here shows the order of visit in case of breadth-first search algorithm. So we are going to use the same logic when we are solving single source shortest path problem, but here we are going to need an extra variable called parent to keep the track of path over here. So in this case, when we come from A to B, in this case, in the parent of B, we are going to set A. So when we come from B to C, in the parent of C, we are going to have B. And when we come from C to D, in the parent of D, for example, we will have C. So we need to create extra variable in which we are going to save the parent of node, which shows that from which node we come to this node. So by doing so, we can easily keep the track of path to come to this node over here. So the path to any given node can be found very easily by keeping track of parent node. So hopefully you have got the idea about the single source shortest path problem and how can we use breadth-first search algorithm single source shortest path problem. Now in the next lecture, we are going to do dry run for breadth-first search algorithm to see how we can use breadth-first search algorithm to solve single source shortest path problem. So see you in the next lecture.